This is the introduction of my project, which is the cloud resource allocation using the particle sum optimization approach. And basically, this project is also available in GitHub, and you can see the source code here. It is written in Dart language, and the UI is made with Flutter. And basically, I will give the overview of the project. And as we know, the cloud resources, the challenges in cloud resource allocations are the dynamic workload. As we know that the cloud workload fluctuate like significantly, requiring the effective resource allocation. For this, the particle sum optimization plays an important role. So the heterogeneous resources, that implies that in cloud there are various resources which need to be taken care of or to be allocated in this own manner, and similarly the resources are constants. And basically the overall idea of particle sum optimization is inspired from the nature. It mimics the social behavior of the fish to find the optimal fish or birds to find the optimal solution. And the particle representation is particle represents the potential solution to the problem, and the position and velocity, the particles like adjust their position as well as the velocity to explore the solution space. And it is based on the social improvement and social learning. The particles use their own best, which is known as the personal best or the p best, as well as the swarm's best guide, or otherwise known as the global best, to find their best solution. And basically this is the formula which is involved. And the velocity of the particle I at the time k plus I is dependent upon the velocity of initial velocity vk, and as well as the inertia factor, which generally ranges from 0.1 to 0.4 to 1.4, and as well as the one self-confidence range or self-confidence range, which is the coefficient for the particle itself, and as well as the particle memory influence. And the value of self-confidence ranges from 1.5 to 2.5, and as well as the C2, which is the swarm confidence or the global based or otherwise the overall swarm's intelligence, and as well as the swarm influence. I will show the one demo here. I guess I have it. Let's see. I have stored one GIF. Let's open it with Microsoft Edge. So basically this is how the particle sum optimization work. And all these particles, let me refresh it again. All these particles scatter everywhere and they all converge to one point. This is how the particle sum optimization work. I will show the demo in the moment of time. So basically this is the algorithm. It starts with the initialization, and we evaluate the particle's fitness based on the objective function. And for our objective function we have chosen the mean square error, and the velocity and the positions are updated iteratively, and as well as it converges to a particular point. As we can see here, the best solution is found when all the particles converge to one point. So this is it. And the objective function, as I mentioned, the objective function is to optimize the resource utilization and as well as to reduce the mean square error. And this is all the gibberish. So as the experimental results, we have chosen mean square error, which is calculated as the average differences between the predicted source as well as the actual resource demand. And the mean absolute error is like the average of the absolute differences between the predicted as well as the resource demand. So let's get to the demo. So as mentioned, I have used Flutter. So this is somewhat the UI, which is pretty much generic. So I will guide the what is in the UI. So basically these are the cloud resources, and the overall capacity of the cloud resources is 150 for CPU, and for memory 150, and the bandwidth is 150 units. And here are the tasks, right? 5 tasks, which pretty much these are all is random. So you can also like randomize this thing. And as I have also mentioned, I have also included the auto scaling capacity. For example, the overall cloud resource is 100 here, and the algorithm implemented is here, I guess, here. And this is basically the implementation. I will provide the GitHub link, you can see it here. And I will let me show it here. Sometimes resource also spike to the some limit, and for that the probability is around like 50% chance. And I will refresh it, and sometimes if it exceeds 100 and it exceeds 100, and the overall like the intuitive changes is shown here. For example, let's see some spike. Okay, so here's one spike. And as And for the starting the PSO, here are the tasks which resources are to be allocated like this, and this is the best allocation table, and it will change according to this. I will start the PSO, and as we can see for task 5, uh, it will like allocate the resources accordingly. So as we can see here, the fitness progress, which is basically based on the mean square error, and here is the performance metrics, and here's also the time elapsed. And I'll start the PSO again, and I have used the iteration of around 200, and it will like reduce the mean square error to approximately 0. So it might be a bit congested here in the mobile. I will build Flutter build with, let's do it on the big screen. Is building for the web, I guess. Build cd build plus web. So I will run python 3 http python 3 -m http dot server, and the port number I will use 8000 or 8500. I will use the port number. Let's see it on the big screen, and I will look on it. So this is basically the project. It's on the bigger screen. As we can see, the resources are allocated like this, and resource utilization is also shown here. If I start the PSO, it will like find the best solution and allocate the resource correspondingly, and the performance metrics are evaluated like this. And you can see the algorithm, which is pretty much based on the equation which I shown above. And here are the algorithm part, and for randomizing the resources, for simulating the cloud resource allocation, this is the somewhat random function. I will provide the link to the description. You can see it from there. So this is how it simulates the resource allocation in the cloud environment. This can be scaled up to one big project, for which the data can be shown from the AWS console or otherwise the cloud provider, and the resources can be allocated on its behalf. So this is basically the project themed on the particle swarm optimization.